Hi everyone, welcome back. Lastly, we learned how to initialize this MSER class. Also, we made a comparison with the previous classes we already learned, which is related to this feature detection and description classes. Also, in this video, we are gonna focus to the details of these member functions, which are the parameters of this MSER. If the people who came to here want to know really details about the parameters, they can check the paper of this MSER. We are just gonna focus to the how these parameters change affect the result of our image. So we are gonna focus to the parameter changes into the image result. So we are gonna focus that part. So I'm just telling for informing you. Also, we can switch to the code part. This was the code from the previous video. Extra, I just put into here the parameters to be able to see the default ones, which are these things in here. These are the member functions which we see in the website, and yeah, so we can maybe split and we can see both at the same time. And if we run the code, we were checking, we were making an example by on this blur image, and lastly we just our result was giving us the change, replacing the pixels of the region pixels with yellow pixels to be able to see, and also we were drawing a rectangle around it, which is also a result which is given by this MSER class. But for this video we do not need this rectangle. I can comment out that one. And except that, yeah, we see the default parameters in here in the console output, and here are those, and we are gonna go by one by. Before starting, I need to tell some of these functions are only for color images. You see in here also they are giving an explanation. So we were converting the 3-channel image into the 1-channel in the previous video. So first of all, I'm gonna focus to the which are working with both the 3 and the 1-channel images. So we are gonna continue with the both supported one, then we are gonna switch to the color ones. Okay, so actually these 3 is supporting both, so we can continue with this one. And yeah, the delta is basically we can start. Delta is just deciding how much accuracy or how much detail you want. So decreasing this the delta value, which we can do it in here. Also, I want to see the result. For example, in here 393 regions are detected, so we see them, and by the change also we can see not only the image result, we can only see the how it's affecting the number of the results. Okay, so MSER dot set delta, so we can make it 2 if it is 5 defaultly. So how it's gonna affect, let's see. So you see now the number of the detected regions are increased to 500 from 393. So also in the other time, if you increase that, it's gonna give you more rigid regions. You see some small ones are eliminated. So this is basically just the we can say the details. If you do not really detailed regions, so you can increase this, so it's can also increase your efficiency. So this was the first one, so we already done this one. And the next is this minimum area and the maximum area. This is very simple. This is deciding, this is giving a threshold, how many pixel regions you want to detect, what's your interested area. So by just calling set minimum area into the, let's say, defaultly they are, by the way, 6 to 14,000 pixels. We can call minimum area to, let's say, 5, which is very small, and dot set maximum area, which is, let's say, 20. Now our expectation, we are not gonna see the regions which whose area is more than 20 and or smaller than 5. So you see in here, for example, if we zoom, here is 2, 8, let's say 17. I didn't count detailedly, but you see the maximum region is gonna be 20. So this is basically just filtering that area. Now we can switch to the color ones. We can remove this BGR to gray, so we are gonna directly focus to the 3 color images and see how it's working. Lastly, so it's only giving us here, it's not detecting the others because of the parameters. Okay, So 3 regions we are getting. So this maximum variation is actually just deciding the stability, maybe we can say. So it's giving the default value is 0.25. So if you decrease this, it's gonna decrease the variation. In that way, we are expecting to see more regions. Let's say set maximum variation, which is gonna be, let's say, give a weird number. We see still same. What happens if we increase into the, let's say, 9? Oh, we still see the same. But what about if we just change this one to gray? Oh, it's working with gray images also, or I'm wrong? Oh, variation. Oh, so sorry, for the variation also there is no limitation. 442. Yeah. So decreasing this from, let's say again, the 0.25, which is the default one, is 393 giving. So if we decrease it into the, let's say, 0.01, so it's gonna give us decreasing the variation. So yeah, so it's gonna give less results. Okay, so increasing that is gonna give more results. This is basically in the documentation is say for the stability. I don't know in here written. Okay, for the stable regions, you need to decrease the variation. Of course, if you decrease the variation, you are gonna get less results. Yeah, I'm wrong. Okay. Anyway, also this is working for one channel images, so both is okay. Now we can switch to the edge blur size, but I'm sure this is for the color images. Where is that? Oops. Okay, for color images. So default edge blur size is 5. You can think like this is Gaussian blur. We are giving a kernel size, right? So if you make it, also we need to convert this to the color one, and the default is 5, and we see how many results? Let's see, 3. And if we make it set edge blur size, if we make it really high, for example, let's say 11 is high, I think, and you are gonna get, okay, 2. So because you are making more blur from 3 to 2, so because if you make it, for example, 33, I think you are gonna get 0, because we blurred everything, nothing left. In the behind, I'm talking, of course, here we see the result only, but in the behind it's applying really high blur size, so it's removing, I think, all of the edges, so it cannot find anything. What if I make it 1? Okay, now I find more regions, as you can see in here. Okay, this is working in that way. And the next is minimum diversity, and this is about parent-child relation. The default is 0.2. What if I make it, set minimum diversity into, let's say, 0.9 maybe? What is gonna happen? So I only get 1. So before this was filled, actually you see in here, but previously it's actually it's finding this is a region, but it's removed because there is already a parent. So if you decrease the diversity, it's gonna more ignore the parent of each other. So there's already a parent around, which is a detected region, so it's somehow ignoring the inside children region. So if you decrease this, for example, the default was 0.2, let's say 0.01, I'm expecting to see more results. You see, we cannot directly see, but at least it says, okay, this is also a children, but we can still consider because the diversity is less, right? Okay. And this evolution is about the iteration in the behind, also mathematical things. But if you more iterate, you are gonna find more results. For example, the maximum evolution was 200. Let's say make it 100, which is less. And with the default one, lastly we found, let's see, 3, right? Okay. Now by increasing, by decreasing it, maybe it's gonna decrease to 2, let's say, since we don't have much, but 3 becoming 2 because we decrease the iteration number in the kernel size. So if you make it high, let's say 200, now okay, maybe just 200 was default, sorry, let's make it 500. Now you found one more, let's say make it 1000. Now you get other regions, because since it's iterating more, it's finding other regions. And the minimum margin, actually also this is somehow related to the delta, I think, but yeah, the default one was 0.03, which is also very small. Set minimum margin. So if we increase it a little bit, let's say 0.5, we are gonna get nothing, because we really increase the margins. It's more eliminating the small regions. I don't know, here it's written about small things. Ignore too small margin. Yeah, so I don't know what this is meaning, but in the when I searched it, if you increase the margin, it's gonna ignore the regions more, the small the size, I mean effect of the size. For example, the default was 0.03. If you make it really small, what's gonna happen? Yeah, still 3 I got, but yeah, increasing that is removing that 3 regions also. Simply in this video, I just want to talk about the parameters of this MSER. As I said, you can find the more detailed explanations in the paper of this MSER. Yeah, I'm done for this video. Thanks for watching. See you in the next videos.